All right, moving along. Oh, it seems like moving along for me because I'm doing all the polynomial operation videos like back to back. But maybe for you it's been like a day or something like that. So maybe you're not moving. Maybe like moving along, but you know what I'm saying. Oh, sorry, I stepped way too far forward again. So now we're multiplying polynomials. Okay, the correct word we're going to use in this class is called distribution. Right? I will say multiply probably for this lesson, and you probably won't hear it again. Okay, so when we're talking about multiplying polynomials together, or a monomial times a polynomial, any kind of multiplication where there's a polynomial involved is called distribution, or where there are multiple terms, right? Polynomial multiple terms. Distribution, and that's what we're going to say. That's why it's bolded here for you, distribution. Okay, I have some examples here for you in case you didn't want to watch the video or something like that. Okay, but we're going to go through the guided notes together. This one, I keep saying they should be quick. I don't know, maybe I'm just verbose. I guess we'll find out, right? But I think it's pretty quick. I think the easiest way with multiplying polynomials is just to show you. There's the theorems behind it and stuff like that, and I could spiel on, but I think doing an example is going to be the easiest way for you to see how it works. So let's do the practice problem on the second page. Okay. All right. Now, first things first. Remember, when there's something touching the parentheses, it means multiply. All right. So if I had parentheses times the parentheses, it would be multiply those two parentheses or those two polynomials together. Okay. Now, distribution, in its most basic wording, is multiply everything in the first polynomial times everything in the second. So every term in the first polynomial times every term in the second. Okay, a lot of times you'll see this on the front page. They'll show kind of connecting arrows. Okay, so we have a monomial times a binomial. So everything in this polynomial, which is only one thing, I started us out nice and slow. This times everything in this polynomial, so each term. So 2 times negative 3x. And 2 times 1. Okay. Now 2 times negative 3x, remember this is all multiplication. Okay, multiplication has the community property. Okay, if you don't remember that or your teachers didn't teach you, I'm sorry that they stole from your education, because usually they don't teach it, or it's very, very brief. But it's extremely important. Community property or commutative property just means it doesn't matter what order you multiply, right? 3 times 4 times 2 is the same as 2 times 4 times 3. Okay, it doesn't matter the order. So we can do 2 times negative 3, which is negative 6, times x, negative 6x. Okay, and then 2 times 1 is 2. Bam, we're done. All right, fully simplified. Okay, these are not like terms. This has an x, this doesn't. Not like terms, can't add them together. That is fully simplified. All right. So pretty quick, huh? Not too bad. Okay, let's step it up a notch. Five y plus 2 times 3y minus 2. Okay, this is the next example I have written here for you. All right. Now, remember, distribution means every term in the first polynomial times every term in the second. So the first one times every single one. And the second one times every single one. So you're actually going to be doing 4 multiplications. All right, now, if you use some of the other resources that I post for you, which is perfectly fine, right? I don't care who you learn it from, just learn it correctly, okay? They will teach you something called FOIL, okay? So help me, if I hear you say the word FOIL in my class, ooh, okay, FOIL is a bad word in this class. A lot of other teachers will say FOIL. FOIL is not correct. FOIL is a nice little acronym to teach you how to do a binomial times a binomial. But what happens is it ends up hurting you because they don't teach you the differences and what makes it only work for one thing. Okay, so FOIL is a method that only works in this instance. Never with anything else, never works. You can't use it. It only works when it's 2 terms times 2 terms. That's the only time, and that's why I hate it so much. Okay, because it doesn't always work. It only works in one instant, and there's infinite, right? You can do 3 times 3. You can go 2 times 2 times 2. You can go 4 times 2 times 3, right? Those are many terms. This won't work. Okay, so that's a bad word. If you want to learn FOIL and keep it to yourself, go ahead, right? That's your prerogative. But in my class, I will never, ever, 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 ever say FOIL is a bad word. Okay? We use distribution. Every single term in the first polynomial times every single term in the second. So 5y times 3y. 5y times negative 2. 2 times 3y. 2 times negative 2. Okay. Now, 5 times 3 is 15. Y times y is y squared. Okay, y times y, we're multiplying it twice. Exponent of 2. 5 times negative 2 is negative 10. And then we have our y being multiplied. 2 times 3 is 6, and our y being multiplied. And then 2 times negative 2 is negative 4. Now let's combine like terms. Okay, we have 15y squared. We have a y and a y here. So negative 10 plus 6 is minus 4y minus 4. And there's your answer. That's your binomial times binomial. Okay. Now remember, every single term in the first times every single term in the second. All right. So it's not too bad. Pretty fun. I'm sure I wrote it's best of both worlds in the guide. Yep, best of both worlds. It's fun and it's easy. All right. So let's. We got 4 practice problems on the last page. Let's do those ones together to reinforce the concept as best as we can. And then make sure you do the practice problems. All right. If you don't do the practice problems, you're not going to pass. Okay, I'm sorry. It's just how it is. You got to practice. Okay, 5 times 3n minus 5. 5 times 3n plus 5 times negative 5. So this is 15n. 5 times negative 5 is negative 25. And there's your answer. Pretty quick. Okay, the next one. 2p plus 3 times 7p minus 4. Every single term in the first times every single term in the second. Okay, so 2p times 7p times negative 4, 3 times 7p, and 3 times negative 4. So we have 2p times 7p and 2p negative 4. And 3 times 7p. And 3 times negative 4. Okay. 2 times 7 is 14. P times p is p squared. Right? 2 times negative 4 is negative 8 times p. 3 times 7 is 21 times p. And 3 times negative 4 is negative 12. Okay, collect like terms, combine like terms. 14p squared. Negative 8 plus 21 is positive 13p minus 12. There's your answer. It's fully simplified. All right, let's do the next one. Got some fractions in there. You excited? I am so excited. Oh, don't you just love fractions? Oh, also, because you're not going to be in class very often, I should probably tell you this now, because I'm expecting all of you to watch the video. In my class, no mixed numbers. Okay, we're not in elementary school anymore. We don't use mixed numbers. Okay, 3 1/4. No. Okay, the only place in life that I've ever seen mixed numbers is in a recipe or at like a gas station. Right? Like gas stations, they'll have like, oh, it's $2.45, and then really small off to the side, they'll say, and 9/10 of a cent. Right? For some reason, I have no idea why. It's like they're trying to round up a cent without showing you that they're rounding up a cent. No mixed numbers. Okay, if you have something that's 3 1/4, okay, write it. Excuse me. Write it as 13 over 4. Okay, we're going to write it as an improper fraction. All right. With that being said, let's do 1/2 r minus 3 halves times 1/8 r plus 1/9. Ooh, don't you just get goosebumps doing fractions? Okay. So we have 1/2 r times 1/8 r. And we have 1/2 r times 1/9. And we have negative 3 halves times 1/8 r. And we have negative 3 halves times 1/9. Okay. 1/2 times 1/8. Remember, when you multiply fractions, you don't need a common denominator. You multiply numerator times numerator, denominator times denominator. So 1 over 16 r squared, right, r times r, plus 1/2 times 1/9 is 1 over 18 times r. Negative and a positive makes a negative. Okay, 3 times 1 is 3. 2 times 8 is 16. R. Didn't really think ahead, did I? And then negative and positive is negative. 3 times 1, 2 times 9. Now, some of you might have caught this already. I'm going to do it in a second. But when you multiply, this can simplify. Right? You can do a cross cancellation. I hate that word cancellation, but that's the method it's called. The proper word is reducing. Okay, reduces to 1. Nothing cancels out. Okay, especially in SM3, if you start saying cancel out, you're going to get things very, very wrong, especially when you start graphing, because it doesn't just disappear. All right, it reduces to 1, and you'll see it in the graph. For this, you can divide by 3, and so you actually get 1 over 6. But we'll do that in a second. Okay, combine like terms. So we need to do 1 over 18 minus 3 over 16. Okay. Can any of you think of a common denominator? I didn't think ahead, because now I'm going to have to do it on paper. Let's see. Well, we could just multiply them together and simplify, because I don't want to take too much time up on this. So let's just multiply them together. We get a common denominator. So we have 8 and 4, and then 0, 8, 1, so 288. So this is going to be 16 over 288 minus, now we multiply by 18 here, so we got to do 18 times 3, which is 454 over 288. So we have 1 over 16 r squared minus 16 minus 54. If you take away 10, that's 44. And then another 6 would be 38. So minus 38 over 288. Minus, now 3 over 18 reduces, right? We can divide numerator and denominator by 3. So 1 over 6. Oh, there should be an r here. This also reduces. Always reduce. Simplify, simplify, simplify. We can divide numerator and denominator by 2. Right, so that gives us 19 over 144, r minus 1 over 6. Bam, there's our answer. 19 is a prime number, does not go into 144. Pretty sure. Nope, it doesn't. All right, very last one. (3b minus 3 times negative 2b squared minus 9b minus 1. Everything in the first times everything in the second. Okay, so we have 3b times negative 2b squared and 3b times negative 9b and 3b times negative 1. I think I might run out of room, so I'm going to kind of come down. Negative 3 times negative 2b. Negative 3 times negative 9b. And negative 3 times negative 1. Okay, so this first one is 3b times every single term. And the second one is negative 3 times every single term. If there was a third term, we go the third terms times every single one. Right, every single term here times every single term here. Okay, 3 times 2 is 6. B squared times b is b to the third, right? We're multiplying it b 3 times, so b to the third. Positive and negative makes a negative. 3 times 9 is 27, b squared. Negative and a positive makes a negative. 3b times negative 1 is negative 3b. Negative and negative is a positive. Right, negative 3 times negative 2 is 6. Sorry, that should be a squared. Negative 3 times negative 9b is positive 27b. Negative 3 times negative 1 is positive 3. Okay, there's only one b to the third. There is a b squared and a b squared. There's a b and a b, and there's a 3. Or constant, sorry. So combining like terms, 6b to the third. Okay, and then we're going to do our squares. Negative 27 plus 6 is negative 21, b squared. Negative 3 plus 27 is positive 24b, and then plus 3. And there is your answer. Okay. Not too bad at all. Okay, now I know I haven't said it in the other videos, but just a reminder, okay, I'm here after school if you want extra help or face-to-face help. Okay, but please watch the videos.